Unit 7, Part 1 notes, I can identify the special points of a parabola. First off, some academic vocabulary. We have parabolas. That is the U-shaped graph created by a quadratic function. So it could be a U-shape that you see here in blue on the graph. It could also be upside down, so it could be a U-shape like that. We're going to talk more about that. A quadratic function means you will have an x squared somewhere in the equation. It will have to have an x squared. That's what makes it a quadratic. It will not have anything higher than a 2, so it won't have an x to the 3rd power or an x to the 4th power, but it has to have that x to the 2nd power. Features, what we call an axis of symmetry, which splits the graph in half. So you can see this line right here. It will be dashed when graphed, and you can see it goes right through the middle of the graph. And then on that line is what we call the vertex, and that is the highest or lowest point of the parabola. So here in this opening up graph, we have that it's the lowest point. But if we had a graph that was shaped like this upside down U, the vertex would be at the top, so then it would be the highest point. Additional features include x-intercepts, so that is when you cross the x-axis. And there are also y-intercept. There will only be one y-intercept, and that's when you cross the y-axis. Sometimes a parabola can have no x-intercepts because it never crosses the x-axis. Sometimes it will only have one x-intercept, and that is when the x-intercept and the vertex are the same. And then sometimes you will have two x-intercepts where it crosses the x-axis 2 times. So for our examples, we are going to be given a parabola, a graph of our quadratic, and we are going to identify these key pieces of information. So the first question we are going to answer is this a concave up or concave down quadratic function? This is concave down because the parabola is opening down, and you see these arrows right here. They are pointing down. That's a key indicator of up or down. The next key piece of information is our vertex. So our vertex is that highest point or lowest point, but in this case it's going to be the highest point. And I'm going to drag this purple point here to where the vertex is, which is going to be right there. And now we just need to identify the coordinates of that point, and that point is -1, 0. Remember, coordinates are an x, y pairing. It's at -1 on the x-axis and 0 on our y-axis. The next piece of information is that axis of symmetry. So that axis of symmetry is that dotted line that goes through the vertex. So we're going to put a vertical line right here through that -1 point. And that just cuts that parabola in half, divides it into 2 even sectors. And so that axis of symmetry is going to be x equals -1. It's going to be the same value of the vertex for that x coordinate because it just is that vertical line that goes through x equals -1. So that's the connection between the vertex and the axis of symmetry. The next key piece of information we'll identify is our y-intercept. So that is the point where the parabola crosses the y-axis, which is right here, that blue point. And the coordinates of that are 0, -1. And then the last piece will be that x-intercept. And our x-intercept is actually the same as our vertex. So I'm just going to kind of put the point right above that purple point. Please note that those are the same point, but just so that you can see it's both the vertex and the x-intercept, so it's going to have that same coordinate as the vertex. So it will also be -1, 0. Now, the last thing that we're going to do is we're going to make a table of all 5 points that have been plotted for this parabola. And we're going to start on the left, and we're going to work our way to the right, and we're just going to put all the pairs of coordinates in there. So I'm going to start with this one, which is at -3, -4. And then the next one right here is at -2, -1. The next one is at vertex at -1, 0. The next one is 0, -1. That's that y-intercept. And then the last one would be 1, -4. All right, so one thing to note about parabolas and quadratic functions is if we have the vertex right here in the middle, what is special about that axis of symmetry, because that axis of symmetry is going through that vertex, it's cutting it in half. So you're also going to see that axis of symmetry showing symmetry in our table. And the way you're going to see it is in those y values. So if you see -1 is the y value over here, it's also the y value over here. And then that same thing happens with the -4. It's the y value over here and the y value over here. So you are going to see that symmetry feature, and I'd like you to pay attention to that as you complete your practice today, because that's going to be something that we're going to use as we move forward. So I just kind of want you to pay attention to it and kind of notice how it works. All right, we're going to do one more example, same thing. So first off is this concave up or concave down. You can see that the U shape is up, the arrows at the end are pointing up, so it's a concave up function. Then we're going to locate the vertex. The vertex is going to be the bottommost point now because we're opening up, so it's going to be right here, this lowest point here on the graph. And the coordinates of that are going to be, we went over 2, down 8, so we will be on 2 on our x-axis and -8 on our y-axis. So then that axis of symmetry is going to be x equals 2 because it goes through that vertex point of 2, and we can bring our vertical line right there to cut that graph in half. All right, next piece to identify is our y-intercept. So where would we cross the y-axis? And that would be this point right here. And that is at 0, -6. So your y-intercept is always the point when x equals 0. And then y is going to be the number that you cross at, which here is -6. All right, last piece is those x-intercepts. So we have our x-intercept here and an x-intercept here. And so for that, those points are -2, 0 and 6, 0. So opposite of the y-intercept, x-intercepts are when y equals 0. And then the x number is going to be where we cross on that x-axis. So here's -2, and then here is 6. All right, and then again, we are going to create that table. Again, we will start on the left-hand side, and we will work our way to the right-hand side. So we'll start with that -2, 0 point. So -2, 0. And then we go to our y-intercept, so that's 0, -6. And then we go to our vertex, which is 2, -8. Then we go to this other point here that wasn't a special point, and that would be 4, -6. And then that last y-intercept of 6, 0. So again, the vertex does end up being in the middle. And then you see that symmetry of -6, -6, 0, 0. One thing to note on this one is that our x numbers, we're not going up by 1. they were going up by 2 each time, so there was a split of 2 each time. So that does make a difference with that symmetry piece. You do have to have that same gapping on your X numbers as well. So in that case, because each time we were going up by 2, we did still see that symmetry displayed in our table. So again, that's something I just want you to fill out the table, and then just kind of make note of that symmetry that's happening. All right, that is it for the notes portion. So now you're going to go into your practice. You have some problems that look very similar to what we just did in our video. You can complete them the same way. Identify all those pieces of information. Drag those points over just like I was dragging the points over. One thing to note, if you're doing this on paper pencil, maybe just grab some markers to highlight the points in a different color or some color pencils. Or if you don't have access to those, you can just make like a little note on the screen saying like this point is the vertex, or you can draw some arrows. Whatever works best for you if you're doing it on paper. But if you're doing it digitally, you can just do it exactly the way I did it in the video. And then at the end of the practice, you have a couple questions that are asking you to sketch. So sketch is just a rough drawing. You could maybe put some points on the graph and then just draw your quadratic through there. It doesn't have to be perfect is what that says. It's just a sketch, but it does need to have those pieces of information. So sketch a concave up quadratic function with a y-intercept at -2. So you'd want to put a point where that y-intercept would be, and then just give a rough sketch of a concave up quadratic function that goes through that point. And then you can answer 7 and 8 in the same way. And then reminder, once you are done, please make sure you go to Schoology and complete your check-in.